You are tuned into Edu-ca-te. Welcome. Today we're going to be talking about the chemical bonds. So chemical bonds are intramolecular bonds which occur between atoms within molecules. So chemical bonding is just talking about the bond or the forces that are actually keeping these chemicals together. Remember, we once talked in a video that sodium plus chlorine gives you sodium chloride, right? So sodium plus chlorine gives you sodium chloride. So okay, so what makes these things to actually mix, or what makes these things to actually be bonded is actually things called chemical bonds. So these chemical bonds are actually the intramolecular bonds. So they are called intramolecular bonds. So intramolecular bonds happen between molecules. So the intra, it means that it is between, they occur between or within the molecules. Okay. So yes, this between atoms within molecules, right? So atoms tend to gain, lose, or share electrons until they are surrounded by a full electron shell. So remember that when we introduced the atom, we actually talked about the outermost shell and the valence electrons video. So the outermost shell basically just tells you about the shell of an atom that is in the outermost area. So here we are having helium, for example. Here we're having two atoms of helium, and this is a stable atom because its outermost shell, or the shell that is actually the furthest from the nucleus, is actually the outermost shell, so it is filled. So by filled, it just means that it is a stable atom. So this is called what? A stable atom. If you didn't understand that, you can actually rewind on our video which talks about stable and unstable atoms. So here, each and every atom wants to maintain an octet structure, or rather it wants to fill its outermost shell. So it means if it has got no electrons here, let's say it has got only one electron, like hydrogen. Has got one electron, therefore it needs one electron to actually fill its outermost shell. Therefore it needs only one electron. Therefore this is called a single covalent bond, which will happen between hydrogen and any other atom which is willing to share its electron. So let's actually look at this name, covalent. So what is the covalent thingy? So here the co, it just means there is an interaction. So the core works in general terms, like in cooperation, core interior, all those words which starts with core as a prefix, that just means there's an interaction. And then the valent, it means the valence electrons. So the valence electron are actually interacting between two or more atoms in this case. So we're actually having what? Two or more atoms whose valence electrons are actually interacting with each other. So here we're having hydrogen, for example. Remember that hydrogen actually needs what? Actually needs one electron to fill its outermost shell or to stabilize. Therefore, it can also meet another hydrogen atom which wants the very same thing. So in this case, this bond will happen. So here we're having hydrogen, right? And then we're having one electron, and then here there's actually nothing, and then this is hydrogen again. So these are two hydrogen atoms, or two atoms of the same kind. You can say this is two hydrogen atoms. So you can see that these hydrogen atoms, let's say hydrogen number 1, hydrogen number 2. So hydrogen number 1 actually needs one atom to one electron to fill its outermost shell, or the valence shell. This is called the valence shell. So this one also wants the same thing. It needs only one electron also to fill its valence shell. Therefore, there will be what? There will be a pairing, or actually a sharing. So this interaction just means there is a sharing of what? Of valence electrons to maintain what? A stable structure. So they can actually stabilize and be together as a compound. It will no longer, it cannot just take this electron away for itself and then it is now stable. Hydrogen 2 is now stable, and then hydrogen 1 doesn't exist. this cannot happen. Therefore, they have to share their electrons and actually maintain a stable structure. So let's actually draw this compound now. This is now a combination of these two atoms at this specific ratio. So this is the nucleus here. So now this is now a combination. So this is hydrogen 2. So you can see now we are having what? We are having here one valent electron. Let me actually draw it here. We're having this electron here, so it means there's an electron sharing. These atoms are actually sharing these electrons to maintain what? To maintain a stable structure. You can now see that here we can find 1 and 2, and then that side also we can find 1. We can find 1 and 2, and then now we actually have a stable structure, or a stable or a full valence shell. So by full valence shell just means that there is actual stability there. So it means we're going to have hydrogen, 2 of hydrogens. We're actually having 2 hydrogens which are actually sharing their electrons. Therefore, this is stabilizing, because this, by sharing, it means this electron also belongs here, and then this electron also belongs here. You see, so it means now we have got a stable structure, and then we have got hydrogen, 2 of hydrogen. So this is called what? A single covalent. So by single covalent bond, let's actually look at what it means. The single, it means that there's only one pair of electrons shared. There's only one electron shared, and then the covalent, it means the interaction between the valence electron, and then the bond, it just means that these things are bonded together, or these things are actually together. So if we're going to write this in this stage, you can write H. So this is actually the proper diagram for actually representing a covalent bond, because a covalent bond just talks about the interaction of the valence electrons. Remember, we talked about the Lewis dot diagrams that explain exactly what a valence electrons position in terms of the symbol. So in this case, this is the symbol for the first hydrogen, the symbol for the second hydrogen, and then this is the electron, the valence electron for the first hydrogen, the valence electron for the second hydrogen. Therefore, this is called a single covalent bond. And now we go to a double covalent bond. So this one now is a double covalent bond. It is still a covalent bond, even though it is actually double. So this is a double covalent bond. So let's look at it. So a double covalent bond happens when you have got atoms which actually needs what? Which actually needs 2 electrons to actually fill its outermost shell. So let's look at oxygen for an example. Oxygen actually has got 1, 2, 3, 4, 5, 6. You can actually see that this is not actually balanced, so it means that there is 2 electrons actually in shortage. Let me actually draw it properly here. So we're having the symbol for oxygen, and then 1, 2, 3, 4, 5, 6. You can actually see that here we're actually missing 2 electrons which are going to fill this position and this position, so that it can become a stable atom. Therefore, this is not a stable atom of oxygen. Therefore, it will seek to share its valence electrons with another oxygen atom, which also needs 2. Therefore, if they are sharing, let's redraw this Lewis dot structure and check what happens if 2 oxygen atoms are actually sharing electrons. So I'm going to represent this with X. Now we've already covered 4 of the electrons. Now we are remaining with 2 for this one. So this 2 is going to actually be here. And now we go to this one. This one we have 1, 2, 3, 4, 5, and then 5, 6 here. You can see now it's actually balanced because we're having two oxygens which have got what? Which have got actually shared which have got a double covalent bond, meaning that two valence electrons were actually shared between these atoms to maintain a stable structure. So this is what? This is two oxygen making oxygen gas. So let's look at the last, which is the triple covalent bond. So triple covalent bond. So this is the triple covalent bond. So the triple covalent bond basically shares 3 electrons. It's just like that. The single was sharing 1, the double was sharing 2. The triple covalent bond is actually sharing 3 valence electrons. So it is about what? The valence or the interaction of valence electrons, or rather the sharing of valence electrons. So here we're having nitrogen, for example. Nitrogen has got 1, 2, 3, 4, 5 valence electrons. So it has got what? 5 valence electrons. So it is actually in shortage of 3 electrons. So it needs what? 3 electrons to be able to fill its outermost shell. Or it must have, in total it must have 8, right? Therefore it must have what? It must have 3 more. Therefore, if another nitrogen atom comes and intervenes and actually comes wanting those 3 electrons, while these nitrogen atoms also wanting, they're gonna be a triple bond. So let's look at it. So here we've got 1, 2. These are the electrons for this first nitrogen, and then that side we are having 1, 2. You can see now we've covered 2 here, 2 that side, and then we actually have 3, 4. Let me actually do this. 3, 4, 5. You see, and then 3, 4, 5. Now this is more stable because it is now a compound. So it makes up a compound of 2 nitrogens actually. So this is what this is. 2 nitrogens. So this is nitrogen gas or nitrogenous gas. So you can see that this is what is a triple covalent bond because there's an interaction here. This is the sharing, or this is the interaction of the 3 electrons of the 3 valence electrons of nitrogen. Thank you for watching. Please don't forget to subscribe, recommend your friends to this channel, and stay tuned.